Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Angles. This video will help you understand angles and their measures, classify angles, and solve for unknown angles using angle relationships. Understand angles and their measures. Let's start with some definitions. An angle is made of two rays that begin at a common endpoint called the vertex. The red and blue rays below form the sides of the angles. So notice the rays both start at the vertex and extend out, forming this angle here between the red and the blue ray. Now let's take a look at a couple more definitions. Angles can also be made of lines and line segments. The next angle shown is made of a ray and a line. It has a measure of 30 degrees. So notice here we have the ray listed, which starts at one point and goes on forever. And then down at the bottom we have a line. This also could have been made, this angle of 30 degrees also could have been made with a line segment. Let's say if I had stopped this line right there, we would have had this line segment and a ray. They also could be used to form this angle of 30 degrees. The arrows indicate that the ray extends forever in one direction, and the arrows on the line indicate that it extends forever in two directions. A protractor is used to measure angles. Here the protractor can be used to check that the angle has a measure of 30 degrees. So let's notice a couple things about the protractor here. Notice we've taken this bottom ray and we've placed the base of the protractor so it is in line with that ray. So we place the bottom of that protractor right in line there. We place the vertex of the angle at the center of the protractor. And now we're simply going to count starting at the red ray up to the blue ray to see the measure of this angle. And so start counting here. We have 10 degrees at this point, 20 degrees at this point, and then 30 degrees at this point. So this angle that we've measured here has a measure of 30 degrees. Now let's take a look at an example that will help you understand how to use a protractor to draw an angle at a specific measure. Example 1. Draw another ray to create an angle that measures 105 degrees. Well, you can see we've got our protractor all set up here. It's centered at the vertex of this ray, and which is soon to be the vertex of our angle, and we've got the protractor here lined up in line with this ray. So now all we need to do at this point is just measure, and so we need to measure 105 degrees. So starting over at the right, we're going to start counting. So here would be 10 degrees, 20, 30, 40, 50, 60, 70, 80, 90, 100, and now we need to go to 105, which is right there. So now I need to draw another ray going from that point down to the vertex of the angle. So I draw that down. And now we're supposed to draw a ray here, so I need to put an arrow on the end of that ray. And so here, this angle that I've created measures 105 degrees. Now it's time to check your understanding of using a protractor to draw an angle at a specific measure. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 1. Draw another ray to create an angle that measures 180 degrees. Well, the protractor is all set up here. We've got the vertex right there at the center. We've got the ray in line here. And now we need to draw an angle that measures 180 degrees. So we're going to count 180 degrees. Well, 180 degrees, we are going to go all the way around the protractor until we get all the way back to this side of the protractor. So actually this other ray needs to be drawn through this line right here. So all I need to do to draw an angle of 180 degrees is draw this line straight out. And there is our angle now that measures 180 degrees. As you can see, that an angle that measures 180 degrees actually forms a straight angle or a straight line. Classify angles. Angles can be classified according to their measure. So here we have a table where we've classified some angles according to their measure. The words acute, right, obtuse, and straight describe the size of an angle. So starting over here on the left, if we have an acute angle, Those angles are the smaller angles, and they measure between 0 and 90 degrees, but not 0 or 90 exactly. So acute angles are greater than 0, but less than 90 degrees. Moving over here to the right now, we have right angles. And right angles measure exactly 90 degrees. You may have noticed this in figures before, that if we draw this little box inside of an angle, that indicates that that angle is a right angle and measures 90 degrees. The next set of angles are the larger angles, and these are the obtuse angles. And obtuse angles measure between 90 degrees and 180 degrees, but not 90 or 180 exactly. So these are the bigger angles, and anywhere above 90 and less than 180, we end up with an obtuse angle. And finally, we end up with straight angles, and straight angles measure exactly 180 degrees. We created a straight angle in the last guided practice, and you'll notice then that we created a straight line when we made this angle. So we're about to look at some figures where we're going to need to name or identify an angle. And there are three ways that we name or identify an angle. The first way, the vertex, can be used to name an angle if the vertex is not used for another angle. So it's easy in both of these pictures. If I describe in the first picture angle D, it's easy to see that that describes just one angle. Or in the next picture here, I could use angle E. And we list those just like this, angle D, angle E. Those are not going to get confused with any other angles, so if that's the case, you can use just the vertex to identify them. However, in scenario 2, we've got other angles. We couldn't call this thing here angle C because angle C is confusing which angle we're talking about. So in this case, where we have lots of stuff going on, we usually use 3 points to identify the angle. And so the 3 angles that are shown here, we could have angle ACB, starting up here at AC and then B. The next one we could do is BCD, which is this angle right here, BCD. And then finally we could take all of these together and take the bigger angle, which is ACD. So this whole entire angle here could be named. So if it's confusing and there's more than one angle at a vertex, we usually use 3 points to identify the angle. Scenario 3 is we can use a variable to identify an angle or talk about the measure of an angle. And so you can see here, we would say that that is angle X. Over here, we would say that that is angle Y. And if we added these two together to get this whole entire angle there, we would call that angle X plus Y. Now let's take a look at some examples that will help you understand how to name and classify some angles in a diagram. Example 2. Name a 90-degree angle in the diagram. Is the angle acute, right, obtuse, or straight? So let's take a look at our diagram here. This angle here is 90 degrees. It's listed. And so we just need to describe that angle. So to describe that angle, I'm going to use the angle symbol. And then I want to make sure that the vertex of this angle B is in the middle. So I could call that angle D, B, E. I also could have reversed that and called that angle EBD. Either way, it still describes that 90-degree angle because B, the vertex, is in the center. Now, is that an acute, right, or obtuse angle? Well, any angle that is 90 degrees is a right angle. So this is a right angle. Example 3. Find the measure of angle CBD. And the way we write this shorthand for the measure of angle CBD is just like this. We just put a lowercase m out front. So that asks for the measure of angle CBD. So let's take a look at our picture. So we have CBD. We're talking about this angle right here. And as listed, it looks like it's 38 degrees. So I would want to say the measure of angle CBD is 38 degrees. And now we need to classify this angle. Now this is a smaller angle. It's between 0 and 90 degrees, so that makes this an acute angle. Example 4. Find the measure of angle CBE. Is this angle acute, right, obtuse, or straight? Well, let's start with a measure of angle CBE. Taking a look over here at our diagram, we're going to start at C, go down to B, and then over to E. So that makes this larger angle right here, all the way across. Well, to find the measure of angle CBE, we are going to need to add these two angles together. So the first one that we see there as part of this angle is that 38 degrees. So we want to add the 38 degrees. The next part of that angle over here is the 90 degrees. And so we want to add that 90 degrees together. So when we add 38 and 90 together, we get 128 degrees. So the measure of angle CBE is 128 degrees. Now this is a larger angle. It is greater than 90, but less than 180. So this is an obtuse angle. Now it's time to check your understanding of naming and classifying angles in a diagram. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 2. Name a 180 degree angle in the diagram. Is the angle acute, right, obtuse, or straight? So we're looking for a 180 degree angle. Well, that's going to make a straight angle. And so I'm thinking if we went straight down this line here, we could get our straight angle. So I would say that is angle F. The vertex of that angle I put in the middle is G and then K. You also could have done that in reverse order. You could have called that angle KGF. Now, is this an acute, right, obtuse, or straight angle? Well, it makes a straight line. In that case, it also makes a straight angle. Any angle that is 180 degrees ends up being a straight angle. Question 3. Find the measure of angle FGH. And we write this as the measure of angle FGH. Is this angle acute, right, obtuse, or straight? Well, first let's find the measure of angle FGH. So we're looking at F, G, and H. And so we're looking at this angle right here. So the measure of angle FGH is equal to 50 degrees. Now this is a smaller angle, so this is an acute angle. Question 4. Find the measure of angle HGK. Is this angle acute, right, obtuse, or straight? Well, let's take a look at this measure of angle HGK. So we're starting at H, GK. So we're looking at this angle right here, all the way across, HGK. And so we're going to have to add a couple angles together to make that one. So we would write the measure of angle HGK is equal to, in this case, that first angle is a 90 degree angle. And we're going to add to that the next angle that makes that up, which is a 40 degree angle. So when I add these two measures together, I'll get 130 degrees. Now that's a larger angle. That's greater than 90 but less than 180. And so this is an obtuse angle when we classify it. Now let's take a look at some definitions. Two angles are supplementary if their measures add to 180 degrees. One angle is considered to be the supplement of the other angle. Two angles are complementary if their measures add up to 90 degrees. And in this case, one angle is considered to be the complement of the other angle. Now let's take a look at some examples that will help you understand complementary and supplementary angles and how to find the measures of these angles. Example 5. Name the supplementary angles in the diagram. Well, if we want supplementary angles, we want angles that are going to add up to be 180 degrees. And angles that add up to be 180 degrees make a straight line. So if we go all the way across here, those two angles together are going to be supplementary because they make a straight line. So let's see. To name that first angle, we would say angle ACB. And the next angle, which we would say is angle BCD. Those are the supplementary angles in this diagram. Example 6. Find the measure of angle A. So we're looking for the measure of this angle right there. Well, we know that if we add these two angles that we just named before, angle ACB and angle BCD, if we add those together, they got to be 180. So I think that information is going to allow us to find the measure of this angle A. So if we take the measure of angle A and add that to the next measure of the angle, which is 146 degrees, those angles are going to have to add up to be 180 degrees. So now all we have to do now is solve for the measure of angle A. To do that, I'm going to subtract 146 from both sides. So I would subtract 146 from the left side, subtract 146 from the right side of my equation. Let's see what we have left. Over here on the left side, 146 minus 146 is 0. So all I'm left with is the measure of angle A. On the right side, I have 180 degrees minus 146, so I'm going to do some subtraction. 6 from 0, I can't do it, so I would borrow from the 8, which makes it a 7. Makes that 1 a 10. 10 minus 6 is 4. 7 minus 4 is 3. 1 minus 1 is 0. So it looks like I'm going to get 34 degrees for the measure of angle A. Now it's time to check your understanding of complementary and supplementary angles. Hit pause in your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 5. Name the complementary angles in the diagram. Well, complementary angles are angles that add up to 90 degrees, and you can see in our diagram here, we've got this little box drawn in this corner, and that tells us that this angle is a 90-degree angle. So the two angles that make that up are going to be our complementary angles. So that would be angle BAC and angle CAD. Those are our complementary angles. Question 6. Find the measure of angle A. Well, we're trying to find the measure of this little angle here. We know that these two angles are complementary, add to 90 degrees. So if I take the measure of angle A and I add that to the next angle, which we have listed up there as 74 degrees, and I add that to 74 degrees, together those things make a complementary angle, which means they're going to add up to 90 degrees. Now I need to solve or isolate for the measure of angle A, so I need to get rid of the 74 degrees here on the left side, so I'm going to subtract 74 from both sides of my equation. And let's see, over here on the left side, 74 minus 74 is 0, so all I'm left with is the measure of angle A. On the right side, I'm going to take 74 from 90. Well, I'll need to borrow from the 9, which makes it an 8, which will make that 0 a 10. And let's see, 10 minus 4 is 6, and then 8 minus 7 is 1. So the measure of angle A then is 16 degrees. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.